Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of balanced brackets. Basically, you're given a string of brackets, and there are three types of brackets. There are round brackets, which are basically parentheses. There are square brackets, and there are squiggly brackets. And it's important to note that every type of bracket has sort of two versions of it, right? There's the opening bracket and the closing bracket for each type. And what you want to do is write a function that's going to take in a string of brackets and return a Boolean representing whether or not that string is balanced. Now, what we mean by balanced is the string needs to have as many opening brackets as it has closing brackets, and every opening bracket has to be correctly matched by an appropriate closing bracket. In other words, if you have a round bracket, a round opening bracket like this, it has to eventually be matched by a closing round bracket. Similarly, if you have an opening square bracket, it has to eventually be matched by a closing square bracket. And on top of that, a square bracket, or as you might imagine, a closing bracket cannot come before its corresponding opening bracket. So, for instance, you would not be able to have this because the closing bracket here comes before this opening bracket. And similarly, you can't kind of overlap different types of brackets together. In other words, you can't have an opening round bracket, then a closing square bracket, and then a closing round bracket, and before that, an opening square bracket. This kind of overlap here just doesn't work and is considered incorrect. So with that being said, how do we solve this question? Well, the thing that you're going to want to do is you're going to want to use a stack. And if you're not familiar with stacks, I would definitely urge you to check out the stack category that we have here on the algoexpert.io website. It'll definitely cover everything you need to know about stacks. But the main property of a stack that you want here is the property of last in, first out. In other words, you can think of a stack as kind of, a list of values, but whatever the last value you put in the stack is, that's the first value that's going to come out. And the reason this is going to be useful for this problem is we want to keep track of every pair of matching brackets, right? For every opening bracket, we want to find its corresponding and matching closing bracket. So somehow we need to keep track of all of the opening brackets. And more precisely, we need to keep track of the last closing or opening bracket that we saw. So perhaps this will make more sense if I go through the actual algorithm with this example that I've got in front of me here. So here we've got this string, and this string is indeed balanced, so you would want your function to return true. And so the way we're going to solve this is we are going to build a stack. I'll represent the stack just as an array here at the bottom, and we're going to start traversing our string of brackets. At each character in the string, we check if our character is an opening bracket. And obviously there are only three types of opening brackets, right? There's the round type, there's the square type, and there's the squiggly type. So we check if our current character, our current bracket, is an opening bracket. If it is, we store it in the stack. So here we're going to start at this first index here, and we've got an opening bracket, an opening round bracket, so we're going to store it in the stack. Now, after this, we continue iterating through the string, and now we're looking at the second index, the second character, which is another opening bracket, so we store it in the stack. Keep moving forward, and we see that we have another opening bracket. It's a square bracket this time, so we can put it in the stack. And now things get interesting, because the next character in the string is a closing bracket, and it happens to be a closing square bracket. So what we're going to want to do when we see that we have a closing bracket, whether it be a round bracket, a square bracket, or a squiggly bracket, if it's a closing bracket, we first check that our stack isn't empty. Because if our stack is empty, that means that we don't have any opening brackets that we could try to match this closing bracket to, right? And so if that's the case, then we know for certain that the closing bracket we're at is kind of alone and unmatched, and so our string must be imbalanced. But if we do have brackets in our stack, and in this case we've got 3 brackets in our stack, then we want to check what the last bracket was, okay? And we want to check that the last bracket actually corresponds to the type of the current bracket that we're at. Because if the last bracket doesn't correspond to the type of our current bracket, then we're also in a situation where our string is imbalanced. Let's just assume, for the case of an example, that the last bracket in the stack had been a squiggly bracket, okay? We would be right now at a square bracket, and we would say, okay, we want to check what the last opening bracket was, and we see that it was a squiggly bracket. And so in that case, we're left with this combo of a squiggly bracket and a square bracket, and that just is incorrect. So if we find ourselves in a scenario where the last value is in our stack does not match the type of our current closing bracket, then once again, we're dealing with an imbalanced string. That being said, if the last value in the stack does match the type of our current bracket, then we're good. So in this case here, we were at a square bracket, and the last value in our stack was also a square bracket. So that is correct. And so what we can do now is we can say, well, okay, we know that our current closing bracket has a matching bracket, so let's just get rid of both of them. We don't need to store the closing bracket anywhere. We know that we found a matching opening bracket. And the opening bracket that we found, we can just pop it off the stack. And that's where this last in, first out property of the stack comes in really handy, because that's just going to be a constant time operation to pop this value off the stack. So here, I'm literally going to grab this bracket here and kind of throw it away, garbage collect it. We can just erase it. And so now we can move on in our string. So we move on to the next bracket, and we see that we've got an opening bracket, an opening parentheses, or parenthesis, so we can just put it in our stack. Keep moving in the string. Now we're at a closing bracket. It's a closing round bracket, a closing parenthesis, and we check our stack. Our stack has values in it, so we might have a matching bracket. And indeed, if we look at the final value in our stack, it is a round bracket. So we know that this round bracket here matches the closing bracket that we're at. So we can just grab it, pop it off the stack, and get rid of it. And now we can just keep doing this. So the rest of this example is going to be pretty straightforward. We get to the next bracket. It's an opening bracket, so we can just store it in the stack. Move on to the next value. We're at a closing round bracket. We see that the last value in our stack is an opening round bracket, so we're good. We can keep moving along in our string. We've got another closing round bracket, so we keep checking the end of our stack, and indeed we've got a round opening bracket here, so we can match it and erase it. And then we continue moving along. This time around, we get another opening bracket. This time it's a squiggly bracket, so we add it to our stack. Then we keep moving. we've got a closing squiggly bracket, and the last value in our stack is an opening squiggly bracket, so they match. And finally, we move to the last value in our string, and it is a closing round bracket, and we've got an opening round bracket in our stack. So we pop it, and we erase it because it matches. Now, it's important to note here that we're not done. Now we're done iterating with the string, so we can kind of move this arrow out of the string. But before we return true and say that our string is indeed balanced, we actually have to check that our stack is empty. In this case, the stack is empty, so we're good. But the reason we have to check that is because if our stack isn't empty, then that means that we have an opening parentheses, or an opening bracket rather, somewhere in the string that is unmatched. So to give you an example, let's imagine that we had an opening square bracket here at the very beginning of the string. Well, here we would be left with an opening square bracket in the stack, and that one would have never been matched. Or similarly, maybe we had an opening round bracket right here at the end, and that would be in the stack as well right now, and it would be unmatched. Or it could be literally anywhere in the string, it would still be unmatched. The point is, if our stack is not empty at the end of our string traversal, then our string is imbalanced. So I guess to repeat one last time, there are a few cases where there are a few cases that you have to watch out for in which your string is going to be imbalanced. One case is if you traverse it entirely and everything is good, but at the end it's not empty. You still have opening brackets. That means it's imbalanced. Or the other case is you're traversing the string and you come across a closing bracket, but the stack is empty, so you have nothing to match it against. Or the third case is you're going through the string and you come across a closing bracket. Your stack has opening brackets, but the final opening bracket in the stack does not match the type of your current closing bracket. In that case, once again, you are dealing with an imbalanced string. So that's how this algorithm works. Now, in terms of space and time complexities, it is pretty straightforward. The time complexity is going to be O of n. Let's write it O of n, where n is the length of the string. The reason it's O of n is because, think about it, you have to traverse the entire string. So immediately there, that's O of n time. And then at each character that you stop at in the string, all you're doing are constant time operations. You're checking whether or not the string is an opening bracket or if it's a closing bracket, but you're only checking against a few characters, right? Because there are only 6 total brackets. One opening round, one closing round, one opening square, one closing square, and so on and so forth. So that's all a constant time operation, right? Checking which kind of bracket your current character is. Then appending values to a stack or popping values from a stack is also a constant time operation. So overall, you really are just doing constant time operations at each iteration in the string, and so you're left with a time complexity of O of n. And then similarly, the space complexity is going to be O of n, where n is the length of the string. The reason it's going to be O of n is because you might be dealing with a string. Well, you might be unlucky and have a string that's literally just opening brackets. So like maybe your string is opening, 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 and it's an imbalanced string. But in that case, you would be storing the entire string in your stack. So that would definitely be O of n space. But even if your string were perfectly balanced, you might have a scenario where it's opening, 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 closing, closing, closing. And so you would have to store the 3 opening brackets in the stack. So you would be storing n divided by 2, O of n divided by 2 space, and that would converge to O of n space. So with that, the space complexity is O of n, just like the time complexity. Now that we've covered the conceptual overview, let's dive into the code implementation to see what this looks like. All right, so we've got our balanced brackets function defined, and it takes in a string of brackets. And the first thing we're going to want to do is initialize some variables. So we'll start with opening brackets. This variable is just going to be a string of all the different opening brackets. It could also be an array, and it's going to basically help us check if whatever character we're at when we traverse our string is an opening bracket. We're just going to say, is that character included in this string or in this array? Similarly, we're going to have closing brackets, which is going to be a string of all the closing brackets, or it could be an array. Then we're going to want to have matching brackets, and this is going to be basically a hash table or Python dictionary, a JavaScript object that's going to map every closing bracket to its corresponding opening bracket. And this is basically going to allow us to have very clean code so that when we traverse our string and we run into a closing bracket and we want to check if the last value in the stack is the matching opening bracket, we can just, check it from the hash table. So here I'm just going to copy paste this Python dictionary that I have here that maps all the closing brackets to their corresponding opening brackets. And now we initialize our stack to be an empty array, and we can actually start iterating through our string. So for character in string, for car in string, we first want to check if our character is an opening bracket. So if car is in opening brackets, that's where we use this opening brackets variable. Then we just want to append to our stack the character, the opening bracket. Remember, we just want to add all the opening brackets in the stack and store them there. Then we can say elif character is in closing brackets. So if our current character is a closing bracket, well, then there are two cases, right? Either the stack is empty. So if the len of the stack is equal to 0, then we just return false, because that means that there are no possible opening brackets to match our closing bracket. And so we know we're dealing with an imbalanced string. Or we do have stuff in our stack. We do have opening brackets in our stack, but we want to check if it is the corresponding type, if it is the appropriate type of opening bracket. So we can say if stack of -1, right, the last value in our stack, is equal to matching brackets of our character. So we pass in our closing bracket. Let's say our closing bracket was a square bracket. If the final value in the stack is the matching bracket of the closing square bracket, which is the opening square bracket, then we simply pop the final value of the stack. That's exactly what we did during the conceptual overview, where we just grabbed the final value in the stack and said, okay, we've got a matching bracket. We can just kind of garbage collect it and keep on traversing our string. But otherwise, if it's not a matching bracket, then we're dealing with an imbalanced string, and we return false. And then finally, we don't want to forget what I said during the conceptual overview, which is when we finish iterating through our string, we're not quite done yet. We just want to check if our stack is empty or not. If it's empty, we're good. But if it's not empty, if there's still opening brackets in that stack, then it's an imbalanced string. So we can just return the length of the stack is equal to 0. If the length of the stack is equal to 0, this will return true. We have a balanced string. Otherwise, it's going to return false because it's imbalanced, because we still have unmatched opening brackets. And so this algorithm is going to run in O of n time and O of n space, where n is the length of the string. I hope this video was helpful. I hope it was informative, and I'll see you in the next one.